Hello, receiving teachers, receiving students, and 7Es. Hello, Mr. Thank you. Sit down. Receiving teacher, in our previous lesson, I did ask you to check the students' work on the exercises they've done. And in today's lesson, we are going to look at two exercises, exercise number 5E and exercise number 6E as corrections. Now, 7Es and receiving students, on the screen, I have exercise number 5, as you can see, and also it is in your student workbook. We are going to check exercise number 5E, convert these percentages into their decimal equivalents. We'll do exercise 5E as an example to convert percentages. 7Es and receiving students, let's correct that together on the board. Seven is and receiving students, we are to convert this percentage to its decimal equivalents, or we are going to convert this percentage to a decimal. Now, I hope you can still remember the steps that we use to convert the percentage to decimal. So let's work out this together. 4%. Firstly, what is the first step that we are going to use in order to find our decimal equivalent? What are we going to do here? What did we say? First, we have to change the percentage to a fraction. Is that clear? We'll change it to a fraction. Now, are we going to change it to a fraction using a common denominator, or what are we going to do? Remember our step? We said when we are changing a percentage to a fraction, always our common denominator will be 100. Because of what? Because of the percentage sign. So this percentage sign simply means it's 4 over 100. Now, it is very easy to change a fraction to a decimal now. As you can see, 4 over 100, in order for us to change this fraction to a decimal, we are going to divide the denominator into the numerator. So when we are dividing with multiples of 10, for example, this 100, we were taught in dividing this, such fractions like this, we are going to move to the right or move to the left. Receiving students in 7Es, we are going to move to the left according to number of what? Zeros appearing. So in this case, we are dealing with 100. As you can see, how many zeros does 100 have? 2. 1, 2. So we have to move 2 places to the left. So we'll start from where it says here, then we're going to move 2 places. 1, 2. So in this missing space here, we're going to have what? 0. So our answer will be 0.04 as a decimal. Is that clear? That's changing from percentage to decimal. Okay? Changing from percentage to decimal. Now, 7Es and receiving students, exercise number 6 on the screen, it says we are going to convert these decimals to percentage. Letter E, we are going to change that decimal to a percentage. So, when you look at exercise number 6, it is the opposite. In exercise 5, we change percentage to decimal. In exercise 6, we are going to change decimal to percentage. Can you see the difference here? Okay, so we're going to start from the decimal, coming back to fraction, and then to percentage to be easy. Again, opposite way, we have a decimal here. So following the backward step, we're going to change this decimal to a fraction. Is that clear? So when we change it to a fraction, our denominator must be always 100. So it will be 83 over 100. Can you see it now? When we change this decimal to a fraction, then it is very easy for us to find the percentage. Because, why? We are going to just change the denominator 100 to the sign, what? Percentage. So, we are going to have 83%. Can you see that? That's very simple. 70s and receiving students, we are going to learn more of this converting between fractions, decimals, and percentage in our next lesson. In today's lesson, we are going to look at using equivalent fractions. On the screen, that is our lesson topic for today. Now, 70s and receiving students, I would like you to write down 2 equivalent fractions for this fraction, 2/3. In your groups, write down 2 equivalent fractions for 2/3. Write down 2 equivalent fractions for 2/3 in your groups. Put your hands up if you are finished, if your group is finished. 70s and receiving students, in your previous lesson you learned about how you can find equivalent fractions. So I want you to list down only 2 equivalent fractions of 2/3. It should be simple. Most of us should be finished by now. Receiving teacher, please write down the answers from the students on the board. I will be doing the same as well. 70s and receiving students, let's find out some of our equivalent fractions. Now let's have some answers. Ruben, what do you think one of the equivalent fraction will be?
4/6.
4/6. He says 4/6. Jubilee, do you agree with him if he says 4/6? Yes? Receiving students? Ruben said 4/6. Class, is he correct? Yes, that's one of the equivalent fraction of 2/3. Very good, Ruben. Okay. One more equivalent fraction of 2/3. One more equivalent fraction of 2/3. Florence.
8/12.
8/12. 70s and receiving students, is she correct by saying 8/12? Very good. 8/12. Class, on the screen, I do have the equivalent fractions like what you have given me. So 2/3, the equivalent fraction will be 4/6 and 8/12. Very good. Let us give ourselves 5 big claps. Thank you. Now, 70s and receiving students, I would like us to work out the following, leaving your answers as mixed numbers. On the screen, I have a problem for you. It is, we are going to add two fractions. Class, in your previous lesson, you were taught how to add and subtract fractions. Now, we have two fractions there. The steps and methods used in adding and subtracting fractions are the same. What we are going to do here is, we are going to see how we can use equivalent fractions when we are adding and subtracting fractions, or how it works, especially when we are using equivalent fractions. So our problem on the screen is 3/4 plus 2/3. So what I will be doing now is, I'm going to write the expression on the whiteboard, and we are going to go through these steps together. And we are going to see how we use equivalent fractions when we are adding or subtracting fractions. So 3/4 plus 2/3. That's the problem for us to solve. 70s and receiving students, we were taught so many ways in working out this problem when adding and subtracting fractions. Now, class, can you tell me what is the first step that you will think of when you are adding and subtracting a fraction, especially with different denominators? For example, on the board, we have two different denominators here. What is the first step? Emmanuel, receiving students, what is the first step? You can tell your teacher.
Find the denominator, find the LCD for denominator.
Very good. The first step in adding or subtracting fractions, especially with two different denominators, it's quite difficult. So to make it easier for you, you have to check the two denominators. For instance, in this case, we have 4 and 3. 4 and 3 are two different numbers. So when you are trying to add them, you have to find the LCD of these two denominators. So, class, what is the LCD for 4 and 3? Cullen.
12.
Very good. So the lowest common denominator is 12. Okay. Now, when we find the LCD, or the lowest common denominator, then it will be easy for us to work the fraction out. But before we do that, this is when we are going to use equivalent fractions. Okay? We are going to use equivalent fractions now. Let's look at the board. We have two fractions. One is 3/4 and the other one is 2/3. Firstly, we are going to find the equivalent of the first fraction, which is 3/4. Now, 7 is, remember, to find the equivalent fraction of these two fractions, our denominator will be 12, okay? Because that's our lowest common denominator. So, to help us find the equivalent fraction for 3/4, we can now have a clue, because our LCD will be 12. So what number should go in the numerator part? What will be the number that will go into the numerator part, and it will be equivalent. This fraction will be equivalent to 3/4. Receiving students, you can tell your teacher. Madeline, Remember how you were finding your equivalent fractions?
6.
6. Madeline, how did you find 6? Did you just guess or what did you do? Madeline? You explain your answer. You may have a reason for saying 6. So how did you get 6? Receiving students, you can also explain your answer to your teacher.
Half of 12 is 6.
Half of 12 is 6. She's saying half of 12 is 6. So that's the reason why she gave 6. What do you others think? Remember, you were taught how to find equivalent fractions. Joshua, help Madeline.
9.
9. Joshua says 9. Class, do you agree with him? Yes. So if you agree with him, then is the clue clear here now? We know that our lowest common denominator is 12. So how did it happen to be 12? We either multiplied with 3 or we divided 4 into 12 and we got 3. Or we can say we multiplied by 4 times 3 gives us 12. So whatever number we multiply with the denominator, we also do the same with our numerator. So 3 times 3 equals 9. So is this 9 over 12 an equivalent fraction of 3/4? Yes or no, class? Yes, of course. It is an equivalent fraction of 3/4. So let's look at the other fraction. The other fraction is 2/3. Remember, our LCD is 12. So what will be the numerator? If our denominator is 12, what will be our numerator? Ruth?
8.
8. Class, she says 8. Is she correct? Yes. You all agree? Yes. Receiving students? Okay, 8. So Ruth is correct by saying 8. Very good. Now, what number did we use to multiply the numerator and the denominator? 4. So 3 times 4, 2 times 4. Okay. Now, by now we found out the two equivalent fractions for these two fractions here using the lowest common denominator 12. So 7 is and receiving students, the next step is we are going to add the two fractions. Okay? It is very easy to add the two fractions because the two fractions have a common denominator. When you are adding and subtracting fractions, when you have common denominators, then it will be easier to add and subtract. But if you don't have common denominators, then it will be quite difficult. So we have already found out the common denominator and also the equivalent fractions for each of the two fractions. So let's complete our working out. The first fraction we used was 3/4 and the equivalent fraction is 9 over 12. So we write 9 over 12, the sign, operation sign plus, the second fraction is 8 over 12. That's the equivalent fraction of 2/3. 8 over 12. 7 is and receiving students. Is it easier to add now? Yes, because the two fractions have a common denominator. So, what are we going to do is we are going to add the numerators only. So, 9 plus 8, 17. 17 over 12. 17 over 12. Is 17 over 12 our answer now? No. What's wrong with the answer? What's wrong with this answer? What do we call this fraction? Kalen, what do we call this fraction?
Improper fraction.
Very good. We have our answer as an improper fraction. But our question says we have to have our fraction in its simplest form. So we are going to make the fraction to become a proper fraction. So what will be the proper fraction? Or we can say we want our number to be in a mixed fraction or mixed number. Melvin, what is our answer then?
One whole and 5/12.
Melvin says 1 whole and 5/12. Is she correct, receiving students? Yes. 1 whole and 5/12. Very good. 70s and receiving students. Now you have seen how you can use equivalent fractions to make it easier for you when you are adding and subtracting fractions. Again, please remember, when you are trying to add the two different fractions, meaning that you have two different denominators, first you have to find the LCD and then find the equivalent fraction using the lowest common denominator. Is that clear now? So, let us practice using those steps by doing these following exercises. Receiving teacher, we are going to do only 2 exercises which are on the screen now. The exercise is on the screen. Receiving teacher, allow the students to work in groups to complete the following exercises. Class, the first exercise says copy and complete these equivalent fractions. You are given a common denominator there. You just find the numerator, which is an equivalent fraction of the other fraction. Is that clear, receiving students? You are going to use those common denominators to find the equivalent fractions of those two fractions. Our next exercise is on the screen now, receiving students and 7Es. Next exercise is work out the following, leaving your answers as mixed numbers where appropriate. You finished the first one? First one. Sorry. Think. See the working out example. Receiving students, if you are finished, you can raise your hand. 7Es, you can raise your hand as well if you are finished. Receiving teacher, please check your students' work. 7Es, if you are finished, you raise your hand. Good. Most of the group members are finished. while waiting for our friends, if you have finished, you check your work with your friends in the group and check to see if all of you have the same answer. If you don't have the same answer, that means that there is a problem. So you discuss how you can find the correct answer. Receiving students, you can do the same as well. Seventies and receiving students, let's correct our work together in class. All biracials down, sit up straight and look at the board. Receiving students and 70s. On the board, I have those two exercises written. Exercise 1, we are going to correct A and B, and exercise 2 will correct only A. B, we are going to correct it in our next lesson. So exercise 1A. Exercise 1A, we have to find a numerator of each of A and B. For example, A, 2/3 is equals to, the answer is not given, especially the numerator, and the denominator is given. So our clue is here. If denominator is 15, then what should be our numerator? And the fraction will make it be an equivalent fraction to 2/3. So 2/3, what is the equivalent fraction that is the denominator 15? Remember, we did discuss the step on how we can find our equivalent fractions. Teresa, can you give us the first answer for exercise 1A? What is the numerator?
10.
10. Teresa, how did you get 10?
3 5s are 15, so
You said 3 5s, or 3 times 5 is equals to 15. Yes. So
2 5.
what will be the numerator here? What are we going to do?
2 5s are 10.
2 times 5 equals
10.
10. 70s and receiving students, is 10 correct? Yes. Thank you, Teresa. Teresa said 2/3, the equivalent fraction for 2/3 is 10 over 15. So that's correct. Thank you. Exercise B, 3/5 is equals to what equivalent fraction? The equivalent fraction as a common denominator, or as a denominator 15 as a clue. So what number will be in the numerator to make it an equivalent fraction of 3/5? Equivalent fraction of 3/5. Bagley.
5 times 3, 15.
Okay, 5 times 3 is equals to 15. Very good. And 3 times
3.
3 equals 9. So our equivalent fraction is 9 over 15. Very good. 70s and receiving students, let's look at the second exercise. Class, what is the first step? What are we going to find? The LCD. So what is the LCD here? 15. LCD is 15. So if the LCD is 15, if the LCD is 15, we are going to find the equivalent fraction of 2/3. Two-thirds. If we are saying the LCD is 15, what is the equivalent fraction for 2/3 with the common denominator of 15? Walter?
10.
10. Class, is it correct? Yes, very good, Walter. 10. So we have our equivalent fraction for the first fraction, 2/3. 2/3 is equals to 10 over 15. So we'll write that on the top. Plus, the other equivalent fraction that we are going to look for is 3 over 5 or 3/5. And our common denominator will be 15. So, what is our equivalent fraction? Tony?
9.
9. Class E says 9. Correct? Yes. Okay, 9. So, we have our equivalent fraction 9. 70s and receiving students, is it easy for us to add the fractions now? Yes. Yes, because they have the common denominator. So we'll just add the what? Numerator. So 10 plus 9 is equals to 19 over 15. Is this our answer? No. It's a improper fraction, so we'll write it as a mixed number. So what will be our answer then? Ruthie?
1 and 1/5.
1 and 1/15. Is it? Huh? Ruthie, what did you say? 1 whole and 1/5. Receiving students, is she correct? Sorry, Ruthie, good try. Huh? Maria, what do you think?
1 whole 4 over 15.
1 whole 4 over 15. Is it correct? Yes. Okay, Ruthie, please check your answer. Okay, it's not this one. The answer should be 1 whole and 4 over 15. 70s and receiving students, by now you should know how to add or subtract fractions and also find equivalent fractions. With that, class, what are the steps that you have learned in today's lesson? On the screen, I have the summary for you, receiving students and 70s. It says, to add or subtract fractions, these are the following things you have to take note of. First one, find equivalent fractions with a common denominator. Secondly, add or subtract the numbers. And finally, you have your answer either as a whole number, mixed number, or a proper fraction when you are adding or subtracting fractions. With that, 70s and receiving students, our key phrase for today's lesson is using equivalent fractions, and our next lesson will be on converting fractions, decimals, and percentage. Thank you, 70s and receiving students, for your participation in today's lesson.